Hey, Tommy.
Hey, Lonnie. This way, that way. It's all backwards over here. Oh, so ready to go. Okay.
So are you the MC today, Tom, or am I?
No, I think Steve's running it. There's Steve.
Hey,
All right.
There I am. Hello, everybody, and welcome to the Tom and Lonnie chat. Today's topic is practical cybersecurity for manufacturing operations. And without further ado, let me hand it back over to Tom and Lonnie.
Thank you very much, Steve. Hey, good to see everybody here today. I'll let Lonnie say a few words, and then we're going to bring our guest speaker in, Dr. Kyle Sleeby from Oak Ridge National Laboratory. He's also known as Cyber Kyle over here. But Lonnie, do you have a couple of words to say before we get cracking?
Yeah, we really are excited about this, and there's a new Cyber for Manufacturing Institute called Simani. There's a couple of national labs, a lot of industry, a number of universities. And we really are trying to look at, how can cybersecurity, not just the large OEMs and not just password protection, but how can you secure your data? How can you secure your systems? And looking at it, not just from the big OEMs, but the small mom and pop shops. So really excited to have Kyle here today to kind of go through some of the things that he's looking at and some of the things that the Institute's looking at. So without further ado, so let's introduce Kyle Sleeby. Kyle.
There he is.
Hey, good morning, guys. How are you?
Good morning.
Awesome. Good morning. And so what Kyle's doing, we're just going to turn loose. Kyle's a staff engineer over here at Oak Ridge National Laboratory. Been here for, I don't know, a couple of years now, something like that. Although it looks like he's still not old enough quite to sort of get on board in the whole bit. But got his PhD out of Georgia Tech in mechanical engineering, really focusing on a lot of the digital manufacturing. As Lonnie said, working really closely with Simani, which is the latest of the manufacturing institutes over at Manufacturing USA. And one of the things I asked Kyle to do today, or we asked Kyle to do, is look. I think everybody knows don't plug a USB stick into the machine tool. It's a bad thing. You can get a virus and so forth. Especially if you find something set out in the parking lot, that says, private pictures do not open, right? I mean, that's exactly, what sort of goes on, or don't click on a bad link, et cetera, et cetera. But really the question is, okay, beyond some of that, I think we all got some simple stuff. And so what we've done is we've asked Kyle to say, hey, what are just a few more things that might be a little bit higher level, to target and so forth to really help to protect your shop. And this is not going to answer every problem out there, but boy, I tell you what, it goes a really long way, because you cannot imagine, how people just, and again, you make the mistakes and so forth, but how they make these mistakes out there. And in general, a lot of the security mistakes, even the big ones, right? What was the big one with wind? What was it?
SolarWinds.
SolarWind. Thank you.
Yeah.
It's got windy city, whatever. Yeah. So, but that initiated with a human being making a mistake and basically saying, "Oh, I think I'm okay there." Nobody saw that, or it was only for a few minutes or a half an hour or whatever the heck it was. So it was initiated by a human error, right? But that opened the door for somebody to get in there. Now, Kyle is not going to solve the SolarWinds problem today, but he really is going to take a look at, I think, something a little bit more interesting than just don't click on a bad link. Yeah. So I think with that, Kyle, you want to bring up your screen and let's roll, man.
Yeah, absolutely. Well, hey, thank you guys again for inviting me on today. It's always a pleasure talking on the Tom and Lonnie chat. I'm pulling up my screen here, and we'll show a couple slides and go over this. There we are. Awesome. And before I get started, I really appreciate the introduction as well. As they mentioned, my name is Kyle Sleeby. I've been a R&D staff member here for about 2 years. Clearly, I look pretty young, but Dr. Curvis, anytime you want to upgrade your BlackBerry, just let me know and we'll hook you up with a real phone, okay?
You've been working on that one. All right, man.
You're come full circle.
Oh, man. Sorry, I couldn't resist.
It's not his BlackBerry, it's his flip phone.
Flip phone, a razor, excuse me.
Oh, that was good. There's
I give up.
Coming out of his nose, man. That was good. Awesome.
All right. Well, we'll dive right on into it. So, I was very fortunate to talk with you guys last year. I think it was about October, and we talked about some of the closed loop control stuff. So I think that's really a great starting point to talk about these industrial manufacturing systems. So modern manufacturing systems today are cyber physical systems, and it's a lot of lingo to mean that they serve both as data consumers and producers. You really can't get by in today's world without producing data everywhere you go. You know, every action you do on a computer, every keystroke that you put on your CNC machine or your manufacturing equipment can be controlled, and it can be used for good to help the process, but it could also be used for malicious intent, right? To act against you, to undermine the work that you're doing in your shop. So data really is a two-way street. And that's a great benefit and an opportunity, but it's also something to be very cognizant of, that this can be used against you, and it can be used to take advantage of your operations. So like I said, modern CNC machines, just to pick one application of standard manufacturing equipment, they're extremely complex, but unlike a computer, which is just a simple electronic device, they are complex composite mechanical systems. Now, what I mean by that is cybersecurity gets very real in this regard when you're working with heavy industrial equipment. You could really kill someone and have a dramatic impact on a company overall if people take control of your machines. They're prone to attack both due to the software and the hardware vulnerabilities, because you have so many different functionalities and these integrated components by the OEMs that come together in a comprehensive platform. It makes it very difficult to protect against. And finally, the vast majority of cyber attacks are unfortunately due to human fault. That's just a factor. Usually it's an error someone makes along the way, unintentional, but that allows an attacker to come in to your machine. So as I mentioned, we have our standard operating system, and I'm going to use this diagram as the basis of our conversation today. Many manufacturing shops will use from a CAN and CAD software design system. They'll generate the tool path, the G code, and immediately send it over to the machine, whether it's on a flash drive or an upload. You guys know this. This is a very common practice, right? Some other shops have some process monitoring equipment that can look at what's going on inside the machine in real time, and others have feedback algorithms that then allow you to control the system and make a better part and a better process. Now, like I said, we're starting with the benefits, right? And then we're going to get into the nitty-gritty details, some of the basic cybersecurities. You can do a lot of feedback mechanisms because of this access to the machine. You can do these things such as dynamic dwell operations and changing the process in situ because it is a cyber physical system. At the same time, you can look at other high-end machining applications like stability determination or even multi-part operation, where you're actively monitoring what's happening inside the system and dynamically changing and switching back and forth between parts. And once again, this is only possible because of those information pathways into the machine. But with every information pathway comes a good bit of security vulnerabilities, and that's what we're going to address today. So as Tom mentioned, that there's a lot of very deep, very computer science intensive cybersecurity practices that are out there in the world. It's one of the most popular fields right now, and it is rapidly growing, with a clear need for it. But today I want to talk a little bit at about a mid-range level. Everyone knows not to plug in a USB flash drive. People understand how easy it is to click on a bad link, but what the IT team tells you, what the standard cybersecurity presentations that everyone has to sit through can be taken to the next level. You can work at just a slightly higher level and prevent 90 to 95% of a lot of these attacks, right? You're not going to stop everything, right? But you're going to make it more difficult. You make it a much, much harder target to crack into and make a much better protection for your machine. So what the IT team always tells you, clearly don't click on bad links, check who sent the email, don't use unknown USB flash drives. And my personal favorite, honestly, is if you've suddenly inherited a fortune from your distant relative, you probably haven't, right? You got to be careful with some of the stuff like this. Today, we're going to talk about some really practical implementations. And my favorite picture walking around a shop, of course, is looking at a cell phone that's plugged into your CNC machine. Unless you have a BlackBerry, plugging your iPhone in or plugging your Android into the CNC machine has disastrous consequences. It is incredibly easy to network your drives and change your machine configuration without actually knowing it. So let's dive right into it. USB flash drives. The common practice right now is using these freebie, potentially foreign-made USB sticks from a trade show. I mean, how many people love going to the trade shows and getting a USB stick from the best manufacturer, from the software provider, or from one of your end users, right, that wants to share and promote their business, right? It's not their fault that these USB sticks are available. That's a great freebie for a trade show, but oftentimes those can have malicious content on it right from the outset. Once again, it's not the fault of the company. It just happens. It's something that has been time and time again. Yes, sir, Dr. Kerfus.
Yeah, let me just jump in, right? And this is, look, so again, I'm a company and I want to put something on a USB drive. And what I'm going to do is I'm going to go off and I'm going to find the absolute cheapest one out there, right? And again, it's not so much, as Kyle said, this is not my fault. But look, I went out. I've got to buy 10,000 of these things, for IMTS, right? And so I go find the cheapest one of the whole bit. And who knows? That's exactly what Kyle said. When I buy them and it's blank, who knows what's sitting out there, and so forth. So that's kind of the key thing is, and in fact, I know over here we have very specific USB drives that we're allowed to use from very preferred vendors because they have been certified that these things are good. And typically, before we even use those, we plug them into a separate piece of hardware that just totally wipes them clean. And I probably just stolen Kyle's thunder, but it's just like I want to drive that point home. When you go buy the USB, think twice about purchasing the cheapest source. Again, it's always are you the best with the cheapest vendor?
Yeah, absolutely. And it's not even about just encrypting them and using a protected USB. It's that each of these USBs are commonly shared from machine to machine, from computer to computer. Everything is kind of a mixed pool of data, right? And when you blend everything together, you open up yourself to a lot of vulnerabilities. So just like Dr. Kerfus said, right? As soon as you get a USB from a trade show, reformat it. You can do this very easily on your computer. It gives you a more trustworthy platform, and it gives you the control over exactly what is on that USB stick. Now, furthermore, it's a really good practice to name the flash drive. How many are sitting around their SanDisk or Logitech, or no one really knows what that flash drive is, or if it's been changed or switched or someone else has used it. But name the flash drive and use it with only one machine. If you're going to use USBs, this is a much better way to do it than a random, common pool of flash drives that you keep on someone's tool cabinet. And everyone's guilty of it sometimes, right? Now, the last thing I'll say about USBs is do consider encryption. I know encryption is sometimes painful. It's really tedious to have to open up your drive every time you want to use it. And there's a right application for that. There's a right time to use it, and there's a time that's not as effective to use it, right? But for the critical applications to protect data and to protect your most sensitive equipment, consider using it. One more good practice of it is actually plugging the USB drives on your machines. You can buy lockable USB keys that physically prevent anyone from actually accessing it at a hardware level, and that's really useful. It's very cheap to do, and it's actually pretty effective at preventing other people from plugging in, formatting, and in doing anything via the USB vector attack. So the next thing is your shop network, right? We know USBs are very convenient to transfer G-code files back and forth. The shop network is very important, and it enables some of the closed loop control and the machine monitoring applications like you see up in the top right corner. So you've got to balance this risk versus the reward. There's some machines where it's critical, and there's some machines where not so much, where you can afford to have a much more secure network and enable the operations. Dr. Hurst, do you have a comment on it?
No comment on my side. I think it's again, even on the networking though, you mentioned, hey, monitoring the whole bit, but I think, it's also the alternative for using the USB key. A lot of these machines are wired into the network, and I'm downloading my G code into it. So you're going to see this all over the place. But back over to you, Kyle. Yep, that's it.
Yeah, absolutely. And the monitored operations are coming. So in the end, machines are going to need to be monitored continuously, not only to verify their actions, which we'll talk about a little later, but also to increase the productivity and understand how we can optimize and make our processes more efficient. So I would recommend to go ahead and get ahead of the curve, to start looking into this. It's a far more secure way of transferring information. A couple of things as well, do not use Dropbox to share files from your CAM computer to your machines. It's really convenient. I know it's awesome to be able to network the drives and have a Dropbox folder right there on the Windows or Linux system, but it poses a huge security risk across multiple fronts. Anything that infects one of your Dropbox accounts is instantly transferred to your machines, and that's a risk that I don't recommend taking.
So,
The other thing
is there any other file sharing servers that are more secure than Dropbox?
Yeah, there is actually. So Windows has what's called SMBS. It's a secured managed file share system. What that allows you to do is have a credentialed and authorized access on your network share. So instead of just using Dropbox with your simple internet connected password, it allows you to create a direct link between two computers and only two computers. And that's one of the things that makes it much better to share information over the network.
And what's that called again?
I believe it's SMBS, if I remember correctly, is the right acronym for it. It's a file sharing protocol developed by Windows.
Yeah. Actually, maybe a future topic if we wanted to go down for a Tom and Lonnie chat.
Yeah, absolutely. Yeah. And we're going to talk a little bit about the networking settings as well in just a couple slides that allow you to effectively communicate between your computers and your machines without opening it up to the other vulnerabilities as well. There's a lot of little tricks you can pull that, just like you said at the start, they're not the greatest cybersecurity, the newest trends, but they're very effective and they really help cut down your attack vectors and the surface opportunities.
Right. And as Kyle mentioned before, in terms of, for example, just Dropbox, right? We have it up there. Look, if every one of your machine tools is on your Dropbox account, and everybody in the office, everybody's using a common Dropbox, right? And then somebody in the office clicks on a bad link, and it happens, right? People just mess up and it happens. And all of a sudden, everything is encrypted. Now via Dropbox, everything is encrypted, right? I mean, all of your machines are attacked and so forth because they're all connected up in this unsecure fashion. So again, it's one of these things where you don't think about it, but all of a sudden, boom, it could just happen. And one office machine, right, or even somebody at home, right, doing some work at home, one evening, clicks on it, and bam, it just takes, just takes out all of your CNC equipment. So, but back over to you, Kyle. You can just see where these things go.
Yeah, and most people, unintentionally, no fault of their own, they'll install a network and connect their machines, but they never get beyond the base settings of their router or of their Wi-Fi, right? You plug it in and it works and it's great and awesome. And because of your bottom line, you move on to bigger and better things. And, that's a valid point, right? But there are some simple tricks that we're going to get into here that show how you isolate these networks, how you prevent unauthorized access and make sure that only the protocols that you would like are enabled on this system.
Kyle, just one other thing. If you could, can you roll back to the last one? Yeah. So the last one, you use the default router and computer passwords. If people have forgotten how to get there, what would you recommend?
Yeah, hard reset your router. So every router on the bottom of it has their default password and the username, and typically it's admin and password. just to be clear, right? But there's a physical switch on the back of your router, both a Wi-Fi router and a cable modem, to hard reset it to the factory default settings. If you have any questions or any concerns that something fishy is happening, go ahead, hard reset your router, and these next couple of slides will walk you through some of the ways that you can protect it.
Right. And by the way, there have been studies where people just drive around, and just get on everybody's Wi-Fi network with use the username is admin, ADMIN, as you could have had like administrator, and the password is password. And it's just a disaster, right, to do that. So not only for your shop, but make sure you do that for your home as well.
Well, also just on the passwords, the longer the password, the better, right? So it's better to have something like, a phrase that you're familiar with, like Like I have some that I use that I know. It's like, you sing a song or something. It's better to have that than some 8-character random thing. Is that correct? So it's better to have like 30 characters. That's a phrase that you're familiar with than 8 characters of really wicked, weird symbols and letters.
Yeah,
Is that correct?
And again, so you could say something like, I love machine tools, right? That's great. But you what you might do is, as opposed to using the OO in tools, right? You might use 2 zeros, or instead of the S, you might use the number 5.
But there's algorithms that can rapidly try every, it'll go through.
Oh yeah.
The longer the string, it takes longer to crack that password. So
yeah, and there are all sorts. Yeah, and there are all sorts of different things. Like you could basically come up with a passphrase, as they call it, but take out every A. So yeah, if there's an A, you just don't type it, right, and so forth. On the screen. So there's a lot of good stuff you can do, and it makes it pretty easy as opposed to trying to remember some crazy set of characters and so forth. Anyways, I know, Kyle, we're messing you up on your timing, right? That's okay.
No, you're fine.
I owe you for that BlackBerry comment, man.
This is critical stuff. I mean, it's really important to have a deep discussion. Even at the basic things that can be changed to help. It's kind of funny, right? If you don't do this stuff, you'll see the results and the change in your bottom line. But if you do it successfully, you'll never have to look at it again. So, this information transfer, having a shop network, use a managed network switch, use a one source to one destination. As I mentioned before, Lonnie, that you pointed out, it's very easy to look at it on a Windows side and say that only this folder and only this computer is allowed to talk with this machine. And that in and of itself allows you to block out a lot of the other applications and the other protocols that could harm a machine. There's a lot of functionality on most of your systems that allow for user operator-based credentials. Many of the systems out there right now, you just walk up to it and the machine is not locked, nothing's happened. I mean, how many systems can you just walk up and start moving the machine manually, right? So most of these manufacturers have operations to where you can set a credential-based authorization account. Every operator that walks in the morning, log into your machine. If it's inactive or they walk away from it, log out. Make sure that everyone that accesses your machine is authorized. It's also a really good idea to encrypt files. Now, this is much easier to encrypt your files than it is to encrypt an entire flash drive. And I highly recommend doing this. If you're sending a G-code file via email or anything else, go ahead and encrypt it. Use encrypted emails. Start to take these steps to protect yourself against other people accessing your data. So now let's talk about limiting access to other systems. As Tom mentioned, most people just simply set up their Wi-Fi, change one password on and on for the actual router. Change one password for their network itself and never give it a second thought. What I'd recommend doing is actually digging just a little bit deeper, an extra 10 or 15 minutes of work. Yes, sir.
I was going to say, you just hung up for a second.
No. Can you guys hear me again now?
Yeah.
Great. Okay. So once you set up your router, just take an extra 10 or 15 minutes of work to change some of these simple settings and really increase the security of it. The vast majority of routers, the administration page is at 192.168.0.1. That's the standard settings for the vast majority of common commercial Wi-Fi routers. And if you open that and you can type in admin and password as the login, you probably have a problem on your system, right? And this is where we go back into actually hard resetting your router. It will kick people off for a brief moment, but hard reset your router and start and build this up from the ground up. If you are using this router for a machine network, disable the broadcast name. You're the only one that's going to be connecting your machines, and no one else needs to know your network name. Now, this is different from your guest network and from your main internet network, but for your network of where you connect machines, disable the name broadcast. You're the one that's going to be setting it up. And second, set your security mode to a WPA2 protocol and change your pre-shared key. Now, this is very different than the actual password that you just used to implement and access your router, right? This is very different. What this key does is serves as the basis of encryption for the communications between your computer and that router. So you're going to have one password, right, to access your computer, access your machine, but also change that underlying pre-shared key. These are very common, and sometimes they're used across multiple systems. By changing this, you're preventing someone from accessing it at the encryption level. Now, one more thing that Dr. Curvis mentioned was looking at your power level right here at the top of it. Many people blast the transmitting power level as high as possible, and naturally, you want to have the best service at all of your machines. But sometimes you don't actually want that to go outside of your shop building. So a lot of people can drive by and pick up these Wi-Fi networks just simply from sitting their car in your parking lot. Someone that comes in and does a U-turn has already accessed your network and looked at the data that's being sent if it's unprotected. Change this power level to be at the minimum level necessary to where you get a good signal at your machine. You don't necessarily need to blast it everywhere.
Colin, quick question on the pre-shared key. Actually, there are two questions I got for you. I see this with the EDA 862 though, but in terms of changing that, what are we looking at? What characters that we can put it in there, and then once you do change it, I mean, are you going to see any difference in terms of how you operate, or no? You're not really going to see a lot there.
No, you're never going to see any difference in operating this one. This is just going to be a key specific to your router. It's preventing someone from using a default key that was preset on the machine. So once you set this, you're never going to have to look at this again. You're probably not even going to have to remember this key on the router itself, because you can log in and view it. You will have to set the additional password later on, and that's what you're going to use to access your machines back and forth. But this allows you to change the basis of encryption for all the rest of your communications.
And just really quickly, so it looks like, and correct me if I'm wrong, that basically you're going to use characters 0 through 9 and cap A through F, right?
That's correct. And it changes based on the system. Sometimes you can use symbols as well based on your specific router, but it's always a safe bet to stay with just the alphanumeric.
So if I remember correctly, all this encryption stuff is really fascinating stuff, because it goes all the way back to the Roman times in terms of, what you would do is you would have a certain sequence. So you would take something and you would, like, they have the classic, if you've seen that movie Da Vinci Code, where they knew based on some key, they would turn the disks a certain number of clicks and then it would line up a word. This is the same thing, right? In that you have kind of like a whatever it is that you need. So is what you're saying that the factory, this is one of those keys, one half of this key, and that you want to make sure that yours is unique, because you're not guaranteed of that when it comes from the factory. Is that what you're saying?
That's correct. And you never know. They should be changed over time. Typically they are changed and it's unique to a machine, but just to be sure, go ahead and change that and make sure it's unique to you. Like you said, this is like the Enigma machine, right? You have to have that pre-shared, that underlying knowledge of what catchphrase or what string and letters that you're going to type in to decode the message later on. And that's exactly what this is doing.
And by the way, now that Lonnie has mentioned Roman times, this sort of brings up one of my favorite dad jokes that I'll share with you, and make sure you got your video running for this, because you do need it, right? About the Roman that walks into a bar and orders 5 beers. Okay, back to you, Kyle. Sorry about that. Was really bad, but it's like my favorite joke ever. Back to you, Kyle.
Yeah, you can't resist showing stuff like that, right? So, once again, simple Wi-Fi protection. We've talked about some of the router settings. Now let's talk about how things connect to the router. And this is, as we've talked about, this is not, in-depth cybersecurity. This is just really good cyber hygiene practices that we want to use. The vast majority of routers that use an industrial sense have DHCP enabled. And what that means is a dynamic host configuration protocol. So when you connect to your router, it's going to assign you an IP address, and that IP address is going to be used to identify your computer from the gal or guy sitting next to you, right? That's very good for the vast majority of industrial and commercial applications, right? But if you're using a machine-based network, you're not going to have dynamically changing IP addresses. You're not going to have a machine that's randomly connected and drops off after a time. You want to have a very set structure in your IP address, so that way you can block out everything else. So what I recommend doing is disabling DHCP for the machine and critical network. What this prevents, what this allows is for you to set a specific IP for your machine and only enable communication on that IP range. All others IPs are blocked and no one else is allowed to connect to that router. So just by simply identifying your machine and configuring it with the network, you're preventing other people from that vulnerability of coming into your network. This is a quick image showing how to do it. This is very common and is well documented across Netgear, across Linksys, and a wide variety of other common Wi-Fi routers. But it's a really good thing to consider, and I think it can tremendously help prevent other attack surface vectors. So, as Tom and Lonnie alluded to, I'll wrap up today with just a couple of quick slides showing what's coming next in the cybersecurity world. We're very fortunate to be partners with Simani, which is the Cybersecurity Manufacturing Innovation Institute, and they have two primary goals. One, they want to decrease energy usage by making manufacturing more efficient. And two, in the process of doing that, they want to use energy as a necessary tool to secure manufacturing operations. This is a very powerful approach and able to both increase the results on your bottom line by increasing your efficiency, but also protect your machine. So some of the work that we're doing here is very interesting when you look at CNC machines. One of the demonstrations, just to prove out the point of how these vulnerabilities can be leveraged, we actually provided a kind of a war games attack on one of our computers here at the manufacturing demonstration facility. In partnership with Simani, we wanted to look at a challenge coin that you see over here on the right-hand side of your screen. And the running joke with Simani is some people called it Cyman 2, with the Roman numerals 2 instead of the double I. So from my desk, I was watching the machine make this challenge coin. And I had an algorithm that was monitoring the operations that had gotten back into the machine and watched when the operator changed out one of those products and put in the raw stock for the other. At that instant, we changed the G code without the operator knowing. And we were able to produce a challenge coin showing Simani to Cyman 2. It's a very brazen attack, right? You're immediately going to see this on your machines, but it demonstrates the point of, hey, if you can get access to your machines, what other more subtle attacks can you do? It's very easy to see the change in this part, but what if you were to change your parameters in the back and adjust the center of rotation for a lathe or a mill turn system? That's very hard to detect and it's very difficult to prevent. So by doing some of these subtle attacks, you can really degrade a company and a machine over time. And this is what we're trying to prevent. How do we use these cyber hygiene and base level cybersecurity techniques to prevent attacks like this? In partnership with Simani, we're also looking what's called the energy signature for manufacturing. So as we were producing these two coins, you can see the load that the machine in both the X, Y, and Z axes used to produce that coin. Of course, we have to look at some of the shifts. If the operator presses, feed stop or an optional pause and M1 command on the machine, and we have to be able to account for that and line it up. But you can also see the changes. Right there is the virtual and digital signature change from one engraving operation to other, and this is where we change the G code. Over time, we can start to use statistical anomaly detection to look at the energy consumption of the machine for a specific part and build it up over time. And you can immediately see right here on the right side, just visually by looking at a histogram, where the machine operations have been changed in comparison to a normal and a standard productive run. Now, it becomes very interesting when you start to compare these energy signatures across multiple machines and multiple setups. And one of the things that we like to do is look at a position-linked energy consumption. So this is what we call feature-based analytics. As you move from machine to machine, we have to start accounting for tool wear and the equipment age. Maybe one of your Siemens controller machines has been crashed before, but the other hasn't. So that will result in two different energy signatures, even if you're producing the same component. One of the ways that we account for this is looking at a cross correlation of what loads are experienced by the machine at a specific axis position. And we can start to create these graphs and other statistical measurements to understand how that changes over time with machine age, how that changes with tool wear, and what you should be seeing for a particular feature on a particular part. This is really exciting research to me. It allows some of this higher end cybersecurity analytics to be developed and sent out to the mom and pop shops and the SMMs and really get this technology out to industry. Another thing that we've been looking at is onboard verification. This was in partnership with Akuma, where we start to say, okay, if this file is encrypted and we have a hash of it, basically we make a unique identifying key tag that says this is what the G-code file looks at. Once we send that to the machine, can we verify that the file has not been changed? And in partnership with Akuma, we've developed an app that looks at that file and the hash of that file and shows if anyone has changed anything in that file, even down to the spaces and the periods and the exact numerical composition of the G code. So let me wrap up by saying this. The vast majority of cybersecurity operations just rely on common sense. There's a wide world, very, very deep world of high-end cybersecurity approaches and different encryption mechanisms and side channel attacks and, understanding what the machine is doing. But common sense can really help prevent a lot of these attacks. Train your operators to think, to question, and to really understand what they are doing on the machine. Don't just put in a file, stick in your flash drive and run it without any look, but actually understand what that process is. Extra procedures are annoying, but sometimes they're very necessary. Find the right balance, right? There are some systems that are critical to your business operations, and those are the ones that need to be protected. And once you've got your foot in the door and you're comfortable with it, start to expand out to your other machines. Finally, automate the easy stuff. Weekly machine backups. I don't know of a machine tool manufacturer that does not support automatic weekly machine backups right there on the file system. If your machine is compromised, you can easily restore it, look back to a week before or a month before, and bring it back to that point where you knew operations were safe. And finally, I'd highly recommend to work closely with your suppliers and equipment manufacturers. Many of them out there, like Mazak, has a series of hardware platforms to protect your machines and allow only one-way communication or allow secured two-way communication between your CAM computers and your CNC machines. The Mazak Smart Box is an excellent example of this. So with that, Tom and Lonnie, thank you again for hosting me. It's always great to get to go through some of this stuff, and there's some fun conversations to be had about cybersecurity.
That was awesome.
Yeah,
that was awesome, Kyle. So how deep can you go? So like you showed the example of going in and changing the G code. How much deeper can you go? Could you go in and disable like safety interlocks to where?
Oh, absolutely.
Oh, that's terrible.
Wow.
Absolutely. Terrible. So if you think about it, right, on a modern CNC machine, so basically CNC machines that were manufactured from about 2003 onward, your physical button press, that green button, the cycle start, always links back to a bit setting somewhere on the machine. There's always that software side. And if you know where that is, even though it's a physical press, you can toggle that bit and start the machine without an operator knowing. I mean, it's of the utmost importance when we move beyond computers to physical hardware to truly have a secure manufacturing environment.
Wow. That's wild.
Yeah, I mean, I think the a key thing here again, companies will say, "Oh, there's no way to press the go button or cycle start button. You've got to physically be there." But Kyle points it out. Since whatever it was, 2003, it's just how it goes, right? I mean, even your reset button on your computers and so forth that you have to hold down, but those are not hardwired in there, right? They are. Remember back in the old days on the PC, you had that big orange flip switch, man. That did cut power and so forth. The ones today, it just doesn't do that. It doesn't make sense in the whole bit from a variety of different perspectives. But you do have to be very careful about that.
Well, we're talking about like machine tools, but you also can start the same problem exists in robotics. So if you have an assembly line, this ability to, and especially if you have humans around these machines, usually with robots, you have these big cages and stuff. But if you can disable the safety interlocks, when you think you're going in and everything is safe, it may be that it's not. And so that's pretty frightening.
I think the most useful takeaway here, Kyle, was, and also to expand on what they said, thank you so much. This was a really awesome presentation. Yeah. it went into some serious detail without getting confusing. So you kept it really simple, which was very appreciative by someone like me. And I think the other great part about it was it wasn't too fear mongering either, if at all. So that's really helpful. I think the coolest takeaway though is, when it comes to cybersecurity, cyber physical security, your first line of defense in the shop really is your network. And I think another great sort of, like, not really said here, but at least my takeaway was, if it's a small mom and pop like job shop and you're trying to get into Industry 4.0 and have a connected shop, it's really important, like, not only to your first line of defense is a solid and reconfigured by you network, but if you can't grasp that or do that yourself, probably the first step into going into Industry 4.0, tracking data, and more importantly, cyber physical security, you should probably start with an IT department, somebody competent in IT. I also really want to mention what you said on flash drives, because I totally agree with it, and it was fascinating. And I also want to say, sometimes I agree with it. You got to be wary of, like, the cheap foreign made flash drives that you don't know where they came from. But I remember it was just a couple of years ago. I was at Micro Center and I bought a brand new large capacity flash drive. It was from a trusted company like SanDisk, and plugged it in. And instead of reformatting it because I trusted it, which was a huge mistake, it was preloaded with a bunch of SanDisk branded malware. And I hate to throw SanDisk under the bus, but I'll probably get in trouble for that. But it's crazy that it's not even just like the cheap ones; it's the nice ones. They are preloaded with what they claim on, like, the packaging. Oh, these great features to help you with your file management. And it's like, it's BS. Delete it, get rid of it, start from scratch, do your own thing.
And like you said, I mean, it's not even throwing SanDisk under the bus. It's not their intention. They want to provide,
Right.
Everyone wants to provide a quality product. Things just happen along the way. I mean, there's an incredible market out there across multiple nation state agencies looking at how we compromise the simple things that over time build up bigger and bigger.
Yeah. So Kyle, is there, as you're going through this, is like, I want this presentation. I really want this. Is there any resources out there that cover this, or, like a primer? So if I'm a small company, something that's like, cybersecurity for mom and pop shops 101, or is that something that maybe we should develop and provide to AMT or whoever? Because I think this was really, really rich. I learned a lot as you were going through this.
Well, thank you. And one of the things I see, Tom Kerf is smiling here. I know there's a number of companies and organizations working on that. I don't know of a singular place where you can find this fully open source without paying for training and a lot of stuff. But I know, Simani and a number of other places are actively working on some of this industry engagement. The one pagers, the two pagers that show, hey, a step by step, if you have this router or if you have this setup, here's the easy stuff. So to answer Greg, I don't know of one quite yet. I know it's in the works, and we really should get behind it.
Yeah, because I'm telling you, when you were going through that, I was like, I want that presentation. Because it was really good. It really stepped through step by step things that you can do.
Well, and not only that, right? I mean, it's not only for your shop. I mean, some of the stuff is, I think, pretty reasonable for home. Now, look, I mean, you saw the smart box. The reality is, smart box has a router in it, but it's a Cisco router. It's sort of it's a couple of notches up from the one you go to. If you go to Amazon and get the lowest cost one, or Best Buy and say, hey, this is a good one, and I hope that you might have at home. And again, it's not to knock the low cost ones, but at home, in terms of security and so forth, lower probability. Why is somebody going to be breaking in, and in particular, as Kyle said, nation states and so forth, right? I mean, 30, about a third, right? 34% of all the cyber attacks are against manufacturing facilities because they want your IP. And these are ones where you don't even know you're being attacked. So they're not messing with your machines and so forth. They're just out to get information. from it. That's sort of the bulk of the attacks. And so really you probably don't see as much, in your home network and so forth. And so it is a good investment to get something a little bit higher end, that is professionally managed and so forth and hardened. But some of these things, look, I mean, the router setup that Kyle was talking about in terms of, well, certainly the password, but even your encryption key, these are things that, if you spend a little bit more time, it even secures things a little bit better off at home. And again, it's just good all the way around. It's just something good to practice. And we are really looking at, what training is available and okay, so how do we start to ratchet up the game? Besides the, don't click on the bad link, don't stick the USB key in. What are some of the other things that we're going to be looking at? And so that is coming along. And keep your, and maybe, I don't know, maybe it'll be a spin-off of this particular podcast. But we will have some of that stuff out there because it's just good all the way around.
Awesome.
All right. We don't have any further questions from listeners. I do want to follow up with one more thing. I also think it's really fascinating that, going back to your routers and your network being the first line of defense for cybersecurity and cyber physical security. It's the other awesome thing for, people in manufacturing doing this is doesn't require any downtime on your machines. I mean, as long as any processes don't require network connections between machines, this won't stop any operations from taking place. Because one thing that every now and then when I'm trolling somebody at an event or whatever, it's like, Steve, what can I do? The first thing to stay on top of cybersecurity and cyber physical security, and I'll usually say, some comment like, update your drivers, make sure auto updates are enabled, and make sure you have the latest version of Windows on your controller. Which, I mean, it's not false. I mean, that's a good thing to do, but just doing something like Russ recently at our manufacturing test bed at the AMT headquarters, he took home our 4 Raspberry Pis that we have as our MT Connect agents for our test bed. He took them home to update them to the latest version of MT Connect. And when he brought them back, screwed everything up. We've got to restart everything from square one. We got to get IT in it. It that tends to do more harm in the short term than it does good in the long term, but that's not necessarily true. But it can cause a huge amount of downtime when you go direct to the device. So it was really cool to hear that, going straight to the network, it is your first line of defense, and it's probably your best line of defense.
Yep.
And the best part, it doesn't cause any downtime, doesn't screw any of that stuff up.
Right.
Yeah, and like you mentioned,
go ahead, Kyle.
The Windows updates, right? Machine tool manufacturers, we can't expect them to update their Windows software every time, right? I mean, how many Windows updates have you gotten in the last 4 months? I guarantee you it's at least 2 or 3 a month, if not more. That just shows the effort that's being put into attacking particularly Windows-based platforms, not to mention the rest of them, right? So all of these old vulnerabilities, they're well-known, well-documented, and there's a process for fixing them, but they never trickle down to CNC machines.
Right.
And like you said, that first line of defense, that tremendously helps mitigate a lot of these attacks.
I don't mean to flex, but I am on Windows 11.
Oh, nice. But so just sort of pivoting on that one, and I do want to highlight, because some people now might run out to the machine tool and say, okay, hey, let me do my update. A lot of the manufacturers, whether it's a robot or a machine tool, any automation that's got a Windows front end or a Windows system, integrated into it, will not allow that update. And again, so here's the bottom line. So yes, your home computer, you should make sure it's always updated. But I think we've all had the situation where we've updated a Windows, our machine, and all of a sudden the printer doesn't work because there's a conflict with the driver. And okay, and in a day or two, the driver update shows up because somebody has figured it out, and you're good to go. Well, that might be fine for a printer, but if I got $1 million machine tool out there, or even a $50,000 machine tool out there, and I got to make production rates, and it takes it out. So again, this is sort of getting back to Steve's point is look, it's even more important that you've got this other line of defense, because it might be that your machine tool is not updated. Let me let me pivot because I know we only have a few more minutes and we don't want to get in trouble for going over time. I heard from both of you guys, Raspberry Pi and so forth. Kyle, do you have any thoughts about whether it's Raspberry Pi or Arduino and so forth? And so, look, we've been talking, you hear Windows machines, and I think that sort of rolls into things like Linux machines. And, well, in fact, now I sort of let the cat out of the bag, Linux, but, Apple and so forth. So you can get a virus, you can get a cyber attack anywhere. Can you talk for a couple of minutes about what kind of things we might be seeing with Raspberry Pis that people have running out there? Because, again, Steve brought it up, right? Raspberry Pi out there. What's going on? Kyle, any thoughts there?
Yeah, absolutely. So there is a benefit and a downfall to open source, right? Windows machines are not open source. They're heavily protected, very, very carefully source controlled. Because of that, it becomes a little bit harder to find vulnerabilities, but also easier to fix them, right? On the other hand, Raspberry Pis are completely open source. Knowing Linux at a ground level, in some ways that really helps and allows the greater community to find as many vulnerabilities as they can, but it also allows them to protect it as well, right? So there's this trade-off. Some of the things that you work with Raspberry Pis, the open source environment more is a lack of user knowledge of protecting against it, of just accidentally not setting the right settings or enabling connections or changing other opportunities on that enable vulnerabilities, right? So if you're using Raspberry Pis, there's nothing wrong with that. We use them almost daily for a lot of machine monitoring operations. And just like you said, they're perfect for MT Connect gateways, right? Just make sure you have the settings configured correctly. The last thing I'll say about it, there are a number of trusted images for Debian Linux that are published for Raspberry Pis. Look around on some of the more public cybersecurity development research institutes, and you can find a Linux version or a Linux image that is meant to run securely on a Raspberry Pi, and that's a great step towards using them securely in the first place.
And what I would just point out here, and again, maybe not so much on the user side, but look, if you're a company and you're developing this type of capability, whether for internal use or for sales consumption, the ability to say, hey, this is cyber secure because we are using this more secure platform. We've taken these types of safeguards. This is a great thing to put in your marketing brochure and so forth. Yeah, that we're just thinking along the right lines. Not only is it good because you should be doing this, but I think actually it's a big marketing help because a lot of people just don't think about it. And so all of a sudden you've got a little bit of an edge in there. So good. All right. Steve, what do you think? I think we're sort of getting close to the end. Is that correct?
I think it's a safe time to wrap up. We still technically have 8 minutes, but I'm going to say I think we should have Kyle back for another episode, because if you think about it, beginning of his presentation, before we essentially went fully into like USB flash drives, we didn't even touch on like phones. And going back to, not getting too off topic, but I do want to say like half of the Instagram machinists that I follow make their memes while they're running a program on their CNC machines. And you think that they're on their phone, they're making these memes, the phone battery's going down, they need to plug in and charge somewhere.
Yeah.
And a new machinist who probably doesn't know any better is probably going to try to plug in a USB cable into the machine. So I want to know what's next. How do we prevent people from doing things like that don't know any better? And a final wrapping up question, I do want to say, do you think in the future, or maybe even now, are machine tool builders putting features on their controllers like power plug-in sockets and USB sockets that only provide power to a device and don't connect to any of the computer systems whatsoever?
Yeah, so I think all across the board that needs to happen anyways. You already can buy power-only USB cables, right? That's one easy step. But even at a more broad spectrum, increasing the machine tool manufacturers and encouraging them to work with some of the software partners, to work and develop out a holistic cybersecurity platform so you can securely transmit G-code directly from a software CAM package like Hypermill or Autodesk or Mastercam, right? And get that connection to the machines. That true integration is where the security is going to come into play. So I think we need to work all across the board. We need to have a very coordinated effort and help all of these companies work together to develop out the cybersecurity practices.
Yeah,
Sure.
and just I really want to highlight that, right? This issue of I've got to charge my phone, right? Because at the beginning, Kyle did mention, well, you go through and you see a phone, hooked into the machine tool, and you go, why are we doing that? But it's exactly what Steve said. Oh, my phone's running down. Let me just charge it up. And I can't tell you the number of times, right? I've sort of run through a plant and I've seen phones charging on all sorts of USB sockets and so forth. This thing is a memory stick, right? It is a vector for a virus. So that's right on the money, man. It's right
Not only that, it's connecting to an insecure network.
Yes, excellent point. Excellent
Right.
point. And again, see, I mean, you don't think about these things, right? You just, and I even get nervous nowadays when I'm at the airport and it's like, oh, hey, there's a charging station here. I can just sort of plug in and charge. God knows what I'm plugging into over there, right? It's like it's almost like saying, oh, hey, look, there's a piece of candy on the floor. Just eating it, right? All right, good. Hey, well, let's see. We can't put up. We got a couple more. We got a couple more Tom and Lonnie chats. There you go. We've got we've got the November one up there. In December, we've got some AI and so forth. Actually, Kyle's going to be back with JD, one of our other engineers. We're going to talk a little bit about how we might be using some artificial intelligence and so forth and some connectivity. So now we got the machine tools connected and so forth. We can be a little bit smarter about what we might do with the machines, and in particular, in that particular case. We are going to be looking at, chatter control and so forth. And just a little bit of a heads up, usually when you're running your machine, I get some chatter. What do? I dial back on my feeds and my speeds and my depths of cut. What we're going to show is that, hey, maybe you don't need to do that. And in fact, maybe as opposed to dialing back, maybe you want to get a little bit heavier depth, increase your feeds and speeds and so forth. So we stop the chattering the other direction, but we crank up our material removal rates. And then we'll also talk in January. We're going to be talking, and again, this sort of ties in nicely with cybersecurity. In January, we're going to be looking at, we could run. I mean, I think everybody's used to Teams, everybody's used to Zoom and all that sort of stuff. What happens? Look, I mean, you got Microsoft on your machine tool, you got Windows there. I think everybody's seeing the fact that, hey, we can run Excel, we can run Microsoft Word right on the machine tool. What happens when we start to run Teams on the machine tool? So now I've got a network communication capability. What does that buy us? And again, we're not going to get too much into the cybersecurity, aspect of it because we're talking about it here. But if I could run, and that's not an if, because we do have machines that are running Teams. So what are we going to do with machines, running Teams? And I guarantee you, it's not just, hey, let's just have a web conference. It's going to be a whole lot more. So stay tuned in January for that discussion. And
one that might be interesting is, you mentioned the Raspberry Pi, Arduinos. There's a lot that in terms of low-cost, high-performance computing that might be interesting to talk about. And for example, we're working with some guys now on neuromorphic computing, and I didn't know what the heck neuromorphic computing was, and it's a big thing, and especially in terms of machine learning and AI, a completely different architecture, and companies like Intel and IBM are making some big plays on it, and it could really transform. Imagine your little Raspberry Pi being able to do AI for $35. That's what we're talking about. It's really pretty cool.
That's wild.
So it's a completely different architecture, and so it's pretty exciting stuff.
Yeah, well, and I think you just said it so you could use neuromorphic in the podcast.
Yeah, I just wanted to use that word. I had a friend in Atlanta that told me, I said, we're thinking about using RT Linux for controls, and what do you think? And this is way back in like the late 90s or 2000. And I'll never forget what he said. He goes, Lonnie, you use RT Linux if you have a lot of time, no money, and you want to sound interesting at dinner parties. And so I'm like, I want to use neuromorphic computing just so I can say it.
I want to know what kind of dinner parties this guy goes to. It's a little bit questionable. But I mean, along those lines, actually, it is pretty cool. We actually were just having some conversations over here earlier today. So you mentioned, Raspberry Pi, but NVIDIA. So they make GPUs. They're little supercomputers. For $60, $75, you can get some of their lower end standalone, kind of sort of separate little computer that can do a huge amount of processing. I mean, that is a little supercomputer. By the way, same type of chip that's running your graphics boards in your computer. So that is moving along, and that is coming. So that might be something that we'll be thinking about in the future. Anyway, so you see, Steve, even though you said, oh well, we're ending a little bit early, man, oh man, when we say time to stop, we can never quite hit the brakes. We're skidding along there, but I think we're good to go. I'm going to turn it back over to you.
All right. Yeah. Don't even get me started on NVIDIA GPUs. Maybe we'll be able to see those chips again sometime soon. But anyway, Tom, Lonnie, thank you guys so much for an educational and entertaining podcast episode. And Kyle, thank you for being the politest person in manufacturing. Everybody have a great day.
Thanks
All
a
right.
lot.
Take care.